Podia começar, para quem não me conhece, eu sou Euripides Vargas Júnior, professor do Departamento de Engenharia Civil e, pelo menos até agora, coordenador de seminários, até que o outro tome o poder, mas eu gostaria de apresentar então o nosso apresentador de hoje, né, com muito prazer, o professor Timothy Ross, que tem um título aqui um pouco diferente daquele, mas de qualquer maneira o seminário dele vai estar relacionado com aplicações da lógica fuzzy à engenharia associada ao material bambu. Então, rapidamente, o professor Timothy, ele é um bolsista da Fundação Fulbright. This is the second time you come here?
Third time.
Third time?
With the bamboo.
Well,
No, yeah, we went for bamboo.
Okay, but here, in this department.
Yeah.
Third time. Ele já está virando uma figurinha carimbada aqui do departamento, ou aqui da PUC, né? É professor do Departamento de Engenharia Civil da Universidade do Novo México, um grande especialista na área de lógica fuzzy. So, thank you very much.
Obrigado, professor.
Okay. My
Obrigado,
pleasure.
professor Giovanni. Hoje o seminário será em inglês, porque não é meu português não é melhor. Tá bem?
Melhor do que panza, né?
Okay, thanks for coming. Thank you very much. I've met some of you already, and those of you who I have not, welcome to this presentation. You know, I came here on a Fulbright grant about a year ago. I started in July, and this Fulbright project was for 4 months. Well, I couldn't get 4 months into my summer. My summer was only 3 months. So I worked a deal out with Fulbright to do 2 months last summer, 2 months this summer. And in January, I came here on my own time to experience 40-degree temperatures Celsius. Very uncomfortable weather. The place I stayed at, no air conditioning. So I really didn't do any work here in January. So thanks for having me. And I originally came here to study the topic that you see here. Why aren't we using bamboo in engineering? Serious construction engineering. Because we're not using it in the United States, they're not using it primarily, they're not using it in Brazil, but they are using it in Colombia, and China, and Indonesia, and India. But they're not using it for big stuff, like this building we're in. So the question was, why not? So last summer I did a lot of work on the properties of bamboo and the use of bamboo in actually constructing buildings. And this summer I thought, in between I got a small grant awarded to me in New Mexico to actually fabricate some connectors and to test those connectors. What I'm talking about is connectors, is connecting the bamboo poles together. Beams, columns, girders, what we call stringers. Structural engineers know this. So that small grant has allowed me to manufacture some connectors. I'll show them to you today, and the tests are going to be done later, in Julio y Agosto, okay, this year, in the United States. But when I got here in June, I thought, well, pretty much I know what the issues are, so I started looking at other things. There are many reasons why we're not using bamboo in engineered structures. And they're not engineering issues. They're social, they're economic, they're political. They have to do with distribution channels, production channels, something that a production engineer might work on, not a civil engineer. So I've spent most of my time here looking at these non-engineering things in May and June. I want to talk to you about those. I was also asked by some of the colleagues in electrical engineering to teach a class in fuzzy logic, because that's really my specialty, not bamboo. Well, one student registered for the class here, Marco Antonio de Cunha. So Marco and I have had a lot of private meetings. I'm teaching him advanced topics in fuzzy logic because he's already taken the beginning fuzzy logic class that's offered in electrical engineering here. And so the first half of this presentation is telling you about this bamboo issue and answering this question, why not? And the second part is actually a solution to the first part. The second part talks about 4 different fuzzy logic methods that could be used in improving some of the issues that address this question right here. Okay? So that's kind of where I'm going. And Marco has agreed to be my slide flipper here. So bamboo is everywhere. Here's the equator. And notice these green areas where bamboo grows. Bamboo grows all over Brazil. But most people regard it as a nuisance. Or they just like looking at it. You know, but it's an amazing material. It's actually a grass. It's not a tree. It's a grass. It's the fastest growing plant on Earth. It's also probably the strongest plant on Earth. So we'll talk a little bit about that. It produces 30% more oxygen, and this is the key right here. It sequesters 35% more CO2 than does wood. That's important. That's very important. It grows 30 times faster than wood. That's another key feature about bamboo. Okay? Look at this. Who would not want to have bamboo in their backyard? Of course, here in Rio, there are no backyards, but where I'm from, we have lots of backyards. And there's lots of forests around there. This is gorgeous. Does anybody know where this is?
Sao Paulo.
No. This is not in Brazil.
Não, nós temos, pessoal, São Paulo tem produção japonês, Miyazaki, they have like this, beautiful. Of course, I say, what I'm saying, they're in plan to go.
Yeah.
But this must be in Japan anyway.
No, it's in China.
Japanese.
Yeah, well, it's beautiful, isn't it? Okay, let's go. There's a couple of guys here, Professor Kavami, Professor Posas y Silva. That's not very clear, is it? Anyway, Professor Kavami planted this bamboo grove right outside Lemay. Have you guys seen that? Did you pay attention to the bamboo around here? It's everywhere. And so I'm just listing here, there's some serious research that's been done in China, Colombia, Indonesia, and here in Brazil at a few places on the properties of bamboo. Okay? And that's still not enough, though, to get this stuff being used as a serious building material. It is a serious material in a few of these countries. These 3 are right here. Okay? But they're only building 1-story structures, unless it's a big pavilion, and I've got a couple of pictures for you there. Those are unusual, unique. It's not being used by everyone. Okay? These are the groups I've visited and talked with while I've been on my Fulbright. Several faculty here. There's several faculty at University Nazi Federal Rio de Janeiro. Professors Ney Pereira. Now, he's not a civil engineer. He's a biochemist, but I do have more to talk about his project because it uses a fuzzy model that we're also using with bamboo. Fabio is here, Professors Doria, Cosenza, Gonçalves, and there's some other folks here from down. Thank you for coming. Louis Eustaquio Mojeja, he's one of the PhD students from Professor Gavami's time here. He's doing serious bamboo research in BH, okay? Antonio Mojoso, he doesn't do any bamboo research, but he does physiologic work at an institute called EPEN, which is on the USP campus, Instituto Pesquisa Engenharia Nuclear. Fernando Marinho is a geotechnical guy at USP. He's a former PhD student of Professor Vargas here.
MSc.
Oh,
MSc.
Masters, that's right. He went to London, I guess. He's a geotech guy. He's kind of interested in the use of bamboo to stabilize soil. Maria Luisa Otero de Almeida is at Instituto Pesquisa. How do you say that? Pesquisa Tecnologia, which is another government institute also on the USP campus. Maria studies the use of bamboo for paper. I thought she was a structural engineer. Everybody said, go see Maria. And I said, who does bamboo? When I got there, found out she does paper. Pulp. Well, it was a nice visit. I didn't learn much, but I did learn actually that wood pulp makes better paper than bamboo pulp. So there you go. Nelson Gias works at an organization up in the hills above Friburgo called Pindorama, which is have any of you guys heard of this? Pindorama.org. They do training, which is one of the things you'll see when I get to the problems with bamboo. They train people to plant bamboo, how to grow bamboo, when to cut bamboo and where to cut it, how to prepare it for buildings, and then how to use it to build buildings. Small building, one story, un andar, like a private residence. But this is amazing. And there's a few organizations like this in Brazil who realize this idea of using bamboo for buildings is going to go nowhere unless there's skilled workers who can do this. Ronaldo Quiroz works at a place in São Pedro da Serra, Casa de Saberes, House of Knowledge. And he's building small little bamboo structures. And he's doing training as well. He's only training one or two guys at a time. This place, my friend Andy Smith is here, another American who got lost 35 years ago in Brazil and couldn't find his way out. He's going to take this course right here next year. It's about a 4-day training course, right?
Maybe I'm going to take it this year.
Maybe this year. Okay, thanks. Let's move on. Here's some fairly serious bamboo structures, but they're mostly for sort of look and see kinds of things at expositions around the world. One of these is in Colombia. One of these is actually in the Netherlands. Or excuse me, no, it's Germany, I guess. And a couple, this one's in China, I think this one.
No. If you allow me,
This is
these
great,
are all
right?
in Colombia.
They're all,
This is in
no, one of
Colombia.
these is
No,
in
that one
Germany.
I don't know, but this is in Colombia. I've been there with Simon Vélez. No, on the left-hand side.
One of these is in Germany, but the point
No,
is...
there is a bridge.
No, yeah. I'm not talking about this one.
No, there is a bridge in Germany. I'm sorry.
Yeah.
And that is in Colombia
This
built
one.
for testing, and then they had the exposition in Germany.
Yeah.
They did the same. Sorry.
Okay, no problem. I just wanted to bring this up to show you that they're using bamboo for structures like this, but not structures that are carrying lots of weight and lots of people. Even though bamboo is stronger and stiffer than wood, and we use wood all over the world for 2- and 3-story buildings, it's people and lots of heavy things. Right? Most of the loads on these structures, with the exception of this bridge, are just roof loads, like wind, and none of these are in areas where there's snow. Okay. So the clear benefits I've mentioned, some of them are strength and stiffness. I'll show you a table in a little bit about how strong bamboo is. The high growth rate is a very big positive, big positive. In Brazil, for example, you can't even cut a tree down now without a government permit. But it takes 70 to 80 years to grow a tree large enough to cut down and then use for construction. 70 to 80 years. Bamboo is 2, 3, 4 years. Lightweight. It's lighter than wood. You'll see a table. Low cost. It's less costly than wood. And certainly less costly than steel and concrete. Environmental benefits. I mentioned this one. It sequesters more CO2 than wood. It stabilizes the soil with an extensive root zone. I'll show you the roots. There's no manufacturing needed for the poles themselves. The only manufacturing that we would need is on connectors, like some that I will show you I've invented and am now testing. And this is important for CO2 generation. The steel industry, heavy-duty carbon polluter. Concrete, which uses cement and steel. Heavy pollution. Wood, even though wood is a natural material, it's a manufactured material. Because we don't take a tree and use it in the building. We cut the wood up into rectangular or square sections. We cut the wood for us. We cut it because we have rectilinear connectors. And there's a lot of waste with wood. There's a lot of waste with concrete. There's a lot of waste with steel. Now, in the past 20 to 30 years, these industries have started using their waste. Like the sawdust from a sawmill is being used in making plywood, oriented strand board, several thin kinds of woods that are used in building. Okay. But there's slag that's created when we produce steel. I think that's recycled somehow. Long-term sustainability. If sufficiently treated, bamboo lasts longer than wood. Okay? And we say, well, these things can't last nearly as long as steel or concrete. Really? Steel corrodes. And the reinforcing steel inside of concrete beams and columns corrodes. Bamboo structure can last 50 years if it's treated, and we have to treat wood. So that's not an extra deal. Reinforced concrete doesn't last much longer than 50 years. This building here, Lene, something needs to be done with this building. I've been looking around. Marco here showed me where they've taken a big saw and cut this building into about 4 pieces. You can actually look through and see daylight. Probably Halloween was the reason for that. Well, someone asked me in the United States, hey, can you use this for low-cost housing? Because he sees a huge market in what he calls the $10,000 home. That people could go to the store, buy all the materials they need for $10,000 US and go build a home somewhere on a piece of land. Yeah, it's doable. If the land cost is not part of the $10,000. But this can't really be done except for a small structure where you use, I'll show you in a minute, these kind of connectors that we use now, where you have 2 bamboo poles and you drill a hole through them and put a bolt in there. So this is the kind of joint you have. That's what you saw earlier. Those are what's called pinned-ended members. They're just carrying tension and compression. They're not really carrying bending. And of course, this natural beauty, everybody likes that one. Okay. It's a benefit. So who cannot love this stuff? There's hundreds of species. Some of these other things I've mentioned, right here, LEED. You all teach that here in civil engineering, in construction. It's called LEED credits. In the United States, now you get credit if you follow certain environmental constraints when you produce a structure or you produce anything. It's got 4 credits because it's a rapidly renewable material, it's a low emitting material, it's environmentally preferable material, and it's got a life cycle environmental positive impact. That's 4 credits you'll get in building your structure. I don't know if they do that here in Brazil. Glulam stands for glue laminated wood. It's used to produce very long spans in wood construction. There's now a company that has 23 offices in the world called Bamboo. Bamboo it stands for laminated bamboo. They're doing the same thing with bamboo that they've done with wood. And it's 3 times stronger. A bamboo beam is 3 times stronger with the same cross-section as a glulam beam. So for a smaller cross-section, you can span the same distance, carry the same loads. Okay? The largest bamboo is in Yunnan province in southwest China. It's 36 inches in diameter, 45 meters tall. The 36 centimeters in diameter is about 14 inches. That's big enough for 2, possibly 3 stories, because the wall thickness is about 1.5 inches. However, as Professor Ghavami will point out, this is a rarity. This doesn't happen often, but it happens. So why can't we grow this stuff? Go get the seeds from this plant and spread them around Brazil in the bamboo orchards. Okay. There's a very extensive root zone for bamboo. I've got another picture I'll show you. But this is, of course, as I said, environmentally beneficial because this allows for 3 times the uptake of CO2, a very efficient photosynthetic process. Okay? Very efficient for photosynthesis, more than wood. So if we're worried about CO2 production on Earth, maybe we ought to plant bamboo just for that reason. Forget using it to build. Just plant it. It stabilizes the soil. For example, those mudslides you've had in Brazil in 2011, there's about 10 feet of soil over the last several hundred years that have accumulated on these mohos, which is just a rock face. And when there's enough moisture, it just slid. Maybe this, instead of trees, would have helped a little bit. And of course, I mentioned it's really fast growing. Look at some of these speeds. 5 centimeters in an hour, 12 centimeters a day. Professor Ghavami, one of the ones he planted, you watched it grow something like 10 centimeters in 1 day. Some people from the United States asked me what I was doing down here, and I said, I'm watching bamboo grow. And they believe me. Okay. So this is a cross-section through the bottom of a bamboo plant showing the various, these we call nodes. This is the diaphragm. The distance here is called the internodal distance. This is a variable. It's really interesting. On a single bamboo shoot, that distance is a variable as you go from the bottom to the top. And another interesting thing is, unlike trees, you can't tell how old the bamboo is just from the diameter. Yeah? You have to look at the color and the texture of the surface. And this surface out here is a very hard silicate layer. And so this is this material is much more resilient to chemical, animal, and mechanical exposures. All right, so when bamboo is treated, you treat it for insects, insectos, and fungi. Yeah, is there a question? No, okay.
What about termites, Jimmy?
Yeah, termites.
They don't attack bamboo?
Yeah, they do.
They do?
So you have to treat it with termites and other